This video is mostly for those that join my class late, so that I'm trying to make sure you guys can get up to speed with your notes. So, at the beginning, what we did was scientific measurement and scientific notation. All right, so there are two types of measurements. Measurements can either be qualitative or quantitative. When we're talking about a qualitative measurement, it describes non-numerical forms of measurement. For example, you can tell someone that I feel hot, right? There is no figure to that type of measurement. You just describe a feeling, right? Or I feel warm, or I feel heavy, okay? So these type of measurements are qualitative because they have no numerical value attached to them, right? It depends on the person. This type of measurement is relative. I can touch you and I think that you feel cold and you are like, no, I feel warm because it is depends on the person, right? And so everyone senses it differently. And so you just can't quantify this type of measurement. But on the other hand, you have quantitative measurements. And these measurements, what they do is that they have a definite number, right, and a unit attached to it. So instead of saying that I feel hot, you can say my temperature is 20 degrees Fahrenheit or my temperature is 20 degrees Celsius. That one cannot, usually if you're accurate, you're accurate, right? No one can argue it, right? Because if you're using a measuring instrument, then no one can doubt it because everyone can be able to repeat that result. If I measure it with a thermometer, I will get the same result. If another person does the same measurement, we'll have the same result. So this type of measurement is more precise than a qualitative measurement. So the next thing we need to look at is scientific notation. Why do we use scientific notation? Sometimes numbers are very, very small. When we carry out measurements, sometimes these numbers or these measurements are too small that for us to write that repeatedly, it is going to be time consuming, right? And space consuming too. So imagine that we want to measure maybe the radius of an atom, right? That is going to be a very, very small number. Without scientific notation, if we had to write this number like repeatedly, it is going to take us a lot of time. And sometimes too, measurements are very large, right? Depending on the unit you're using. Sometimes measurements are very large that we also want to use scientific notation in order to condense the way we write, economize space and time. So in scientific notation, there are some rules that we need to be able to apply. The first one is you need to find where the decimal point is. With fractional numbers, this rule is usually very easy to locate, right? It's easy to locate the decimal point in a fractional number. But the problem is usually when you have a whole number. That is why you see, if you don't see a decimal point, then make sure you put one at the far right. Because whole numbers most often, when they are written, they don't have any decimal. So for whole numbers that you don't have a visible decimal, the decimal is at the far right after the last digit on the right. Okay. Now the second rule is you need to move the decimal until there's only one non-zero number to the left. You need to move the decimal until there's only one non-zero number to the left. Now the third one is write the resulting number and add times 10, and then the exponent is the number of times you move the decimal. So if you move the decimal 10 times, right, your exponent is going to be 10. If you move it 5 times, your exponent is going to be 5. Now, if the original number that you had was less than 1, then the exponent is going to be negative. If the original number you had was less than 1, then the exponent will be negative, right? So let's look at an example. So look at this number. You can see the number starts with 0 point so many zeros, right? So you can already tell that this is a very small number, right? It is far, far, far less than zero. So rule number one, you need to locate the decimal. In this case, the decimal is already very clear at the beginning of the number. So 0.00. So the decimal has already been located, right? And then now the next thing you need to do is that you need to move the decimal, right? You move the decimal until, right, you meet a non-zero number to the left of the decimal point. So I'm going to move that 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to move that all the way. So I move it 21 times. Okay. So what do you do? The next thing you want to do is you want to write that number, which is 6.7 times you add times 10, right? And so when you add 6.7 times 10, how many times did you move it? You moved it 21 times. So that is going to be your exponent. Now, because the number was less than 1, your exponent becomes negative. Okay? So this very large number in scientific notation is going to be 6.7 times 10 to the 20, negative 21. So let's try this one. Pause, take some time, right? Take some time and look at this one. So the first thing you want to locate the decimal, right? And the decimal in these two numbers, very clear, right? And so you move it until you meet a non-zero digit. So I'll move it 1, 2, 3. So I moved it just 3. So my number becomes 6.48 times 10. I moved it 3 times 3. And because the number is less than 1, the exponent becomes negative. Okay. So 5.0 again, because if I move my decimal, right, I'll move that decimal 5 times. Okay. So, so if I move it, I'll move it 5 times before I meet a non-zero digit, right, which is 5. And so that's why in scientific notation, these two numbers are going to be written in these forms. I hope you understand. If not, follow up with me in class with a question. Now, sometimes if you go into a door, you need to be able to come out, okay? So if you convert into scientific notation, you should be able to convert them back into ordinary decimal. So if I had this number in scientific notation, how do I convert it back, right, into ordinary decimal? The first thing you want to do is you want to write the non-exponential part, which is a 7.25, and then you have an exponent of -4, right? -4 simply means that I will move my decimal 4 times to the left to convert it back into an ordinary decimal, right? So I will move it 4 times to the left, 3, 2, 3, 4. And so that becomes the number in ordinary decimal, right? Another example would be this one. Again, the exponent is negative and it is 2, right? So I will move my decimal, right, 2 times to the left. So remember, when the exponent is negative, you move it to the left when you want to convert it back to ordinary decimal. Now, let's try it in the other direction. Move the decimal point to the left until there's a non-zero digit, okay? So this is a positive number. What we've been dealing with so far are actually were numbers that were not that positive, but numbers that were less than 1. But now we want to deal with numbers that are far greater than 1. So suppose we had this number to change into scientific notation. Here the decimal is not clear, so we have to, because it's a whole number, put the decimal at the far end. And so we now move it, right, to the left. Now, Remember I said move the decimal to until you meet a known zero digit. With whole numbers, that rule is a big tweak. We tweak that rule a bit so that you see that we do not only move the decimal until we meet a non-zero digit, but we move the decimal until we have a number that's between 1 and 10, right? The number needs to be between 1 and 10. So when I'm moving my decimal, right, I cannot move my decimal and end at 186 because that number is not between 1 and 10. I cannot also stop at 18.6 because that number is not between 1 and 10. I have to keep moving until I get a number that is between 1 and 10. Here I can stop because 1.86 lies between 1 and 10, right? And then I now write it as 1.86 times 10, right? And then times the exponent is going to be the number of time I move my decimal. In this case, it's 11, right? So my exponent is going to be positive because that number was greater than 1. I hope you get it. So let's try this one. Pause this video and try it. If you do try this one, you realize that same rule. For positive numbers, move the decimal until you get a number that lies between 1 and 10, right? So 4.6, how many times did I move the decimal? 6 times, and so that is going to be the number in scientific notation. 234, move the number until you meet a number that lies between 1 and 10, right? 2.34, how many times did I move the decimal? 2 times, okay? And so my exponent is going to be 2. So you can convert it back again. Now the exponent is positive. So if I write 4.56, I'm not moving the decimal to the left because here the exponent is positive. I will move the decimal to the right. Okay. So the number becomes 4,560. Okay. So if I write 1.0, I move the decimal 2 times to the right, right, and the number becomes 100. So the easy way you need to remember this is that big numbers larger than 1, right, have a positive exponent. Small numbers small number less than 1, or small numbers less than 1 have a negative exponent. Okay. All right. So if you buy a calculator, right, I will teach you how to use it. It's very important that you own a calculator because at least you will learn how to use your calculator. You will get used to your calculator and you'll be able to save time each time we have to use them for a test or anything. Okay. All right. I'll see you in the next video.